Hi, my name is Ryan Lee. My teammates are Mani Khan and Jyotsna, and on behalf of our team, I will be presenting our project, Evaluating the Power of Language Models for Time Series Forecasting. So looking to the background of our project, traditional forecasting techniques have been long utilized to predict stock prices, market trends, and economic indicators. While these are effective, traditional models often struggle with nonlinear data patterns and multimodal data, such as stock news, the different indicators, etc. Despite improvements through machine learning and deep learning models, there's always a quest for finding the best model to more effectively synthesize information from multiple data streams. The introduction of language models for time series forecasting represents a potential paradigm shift. Models like Kronos T5 are designed to handle complex sequence generation tasks by understanding temporal differences in complex datasets. And these models are not just limited to numerical data, but are really great at incorporating insights from textual data itself, enhancing overall forecasting capability significantly. So what is the objective of our paper? So we aim to evaluate the performance of Kronos T5, a language model, in forecasting financial time series data, emphasizing its ability to integrate multimodal data sources effectively. So we will benchmark zero-shot Kronos T5 against traditional machine learning and statistical models such as ArmorGarch, XGBoost, and DeepAR to highlight its advantages in accuracy and application in real-world financial scenarios. So the dataset that we use is the FinSPID dataset, which is the financial news and stock integration dataset. It's composed of over 29 million stock prices and 17 million financial news records, which includes the link, news header, and text of different news articles for companies on different dates for nearly 5,000 S&P 500 companies between 1999 and 2023. In our use case, we will focus on Apple data from 2000 to 2019, which is segmented into training between 2000 and 2016 and testing phases between 2017 and 2019. Our target prediction will be generating trading signals, buy, sell, or hold, based on day-to-day price movements, which offer actionable insights for trading strategies. To briefly go into our methodology, we will first perform data preprocessing. This includes feature engineering to generate different technical signals and to incorporate that financial news data into our data set, and embedding transformation. Next, we will implement our Kronos T5 main model, and then lastly, we will implement and then compare our model to a number of baselines, such as ArmorGarch, XGBoost, and DeepAR. So going into the data set preprocessing, first we perform a standard cleaning and standardization process. Next, we will feature engineer our data set to extract key technical indicators from Apple's adjusted close prices, such as simple moving average, Bollinger Band percentage, RSI, PPO, and CCI to use as predictive features. We will also join information on the news lines, news headers from various news sources on different dates. Next, we will perform embedding transformations, which converts financial indicators and textual news into a format suitable for Kronos T5, which will utilize embeddings to capture complex patterns and relationships in the data. And next, we will generate the golden labels, which were 0 for buy, 1 for sell, and 2 for hold, by comparing stocks adjusted close on a day with the adjusted close on the next day. Here's a brief snapshot of our process data in January 2018. As you can see in the highlighted parts, these are the different engineered features, which include SMA, Bollinger Band percentage, and RSI. On the far right, we can see the signals. These are the golden labels for our data, which indicate buy, sell, or hold. Our main model for evaluation is Kronos T5, which integrates the robust capabilities of T5 language models with advanced time series forecasting techniques. It operates by transforming time series data into a tokenized format that can be processed by language models, which allows it to handle both numerical and textual inputs simultaneously. The model also utilizes a probabilistic forecasting approach, making it great at managing the uncertainty inherent in financial markets. We will compare our model Kronos T5 to 3 baseline models. ArmorGarch is a statistical-based model that is excellent at capturing the autocorrelation and volatility clustering in financial time series. XGBoost is a machine learning model that's great at capturing complex nonlinear relationships in interactions between features. And lastly, Deep AR utilizes recurrent neural networks in the form of LSTMs to offer probabilistic forecasts and is really great at handling time-dependent data. Now let's take a look at the results. In zero-shot forecasting tasks, Cronus T5 demonstrated similar performance compared to traditional models like GARCH and machine learning models like XGBoost and DeepAR. As you can see on the left, the median forecast trends upwards, which is expected in a stock market, and demonstrates oscillating behavior reflective in the buying and selling of stock. However, as we take a look on the right, when we simulate our trading strategy on a market simulation, it does show that our trading strategy underperforms the benchmark, which is just the simple movement of Apple stock itself. We evaluate the model performance on mean precision, mean recall, and macro average F1. As shown, zero-shot Cronus T5 does outperform our statistical baseline. However, it does underperform in comparison to XGBoost and DeepAR. This is expected, since both XGBoost and DeepAR were both trained and fine-tuned with time series, as well as dynamic features like financial indicators and news outlet headers, whereas Cronus T5 was tested in a zero-shot environment. To conclude, Cronus T5 does show potential forecasting and trading strategies, but requires improvements for optimal performance. Future enhancements include adopting parameter-efficient training techniques like LoRa to refine forecasting accuracy without high computational costs. In the future, we anticipate a shift towards LLMs tailored for the complexity of financial series, and we expect enhanced model performance through targeted training methodologies aimed at tackling the dynamic nature of financial markets. Thank you.